So today's video is going to be about how to control or how to get the feedback from an IOLink sensor using the CPX-AP-I platform over IOLink, and how to get this data to a Rockwell PLC over Ethernet IP. So it's IOLink or to Ethernet IP. The first thing that I wanted to show you is which IOLink device we're going to be using today, and this is it. It's an ultrasonic sensor from this company over here, and what I'm going to be focusing on mainly at the beginning is how to get this process data here described on this data sheet or user manual. So the output, just true or false, is there something or not, and then the distance with these 14 bits over here. And at the end of the video, I'm going to explain also how to read and write parameters from that IOLink device. Okay. So first of all, or second, I guess, is I have to mention here something. I'm not going to cover every single detail about how to commission or how to start with the CPX-AP-I module, how to, like set up the IP address and all of that. For that, you can go to the YouTube channel from Festo US, and there's these 5 different parts. The ones that I suggest that you have to check if you're starting from scratch is part 1, part 2, and part 5. Okay, so part 1 is basically how to set up an IP address using bootp, and then part 2 covers basic functionality of the web server, and part 5 is how to do the L5X. I'm just going to cover those very quickly here. Right now, I already have an IP address assigned to my device, so I'm just gonna enter it here. And as soon as I enter it on Google Chrome, I immediately get this page because this is what I have connected on my actual hardware. So if I grab this camera and move over here, you're gonna see that I have the, let me get steady, try to get steady here. I have the Rockwell PLC there on the left, and then here I also have the CPX-AP-I Ethernet IP module, and then this is a CPX-AP-I IOLink module. Okay, so these are the 3 devices that I'm using today. In terms of connections, so this blue cable is going to my computer. This cable down here, it's going to the Ethernet IP module, to the CPX-AP-I Ethernet IP module. This cable right here is going to the IOLink module. This cable is going to my IOLink sensor, and oops, this cables there on the bottom are for power. Okay, so let's get back here and let me just try to stabilize the camera real quick so you get a better view. So there we go. I think that's good. So that's what we have there. Now, if we go back here to the software, the first thing that I'm going to do here is I'm not going to change anything here. I'm just going to change something here on the slot number 2, which is the IOLink module. And what I'm going to do is I'm going to change this parameter over here, and I'm going to set it to auto start because I have on my IOLink module, I have the IOLink sensor connected to the first port. The first port is here denominated as port 0. Okay, so auto start, and that's it. The change is taken into effect immediately. I'm not going to change anything here. Now I click on Ethernet IP and then Rockwell L5X Project. And here you can change the, what we're going to do is all of these, so whatever you have here, if you have more modules and you have different parameters here pre-configured, what you're doing is just exporting all of that into an L5X file, and you're going to see the beauty of this. So you just click on here and then you specify a file, a name for this file. Here you can type in station 40 or whatever it is that you're going to be doing. I'm just going to leave it as default. You're going to click submit and then download. Once you download that, you're gonna get an L5X file. You're gonna grab that L5X file and you're gonna open it. Oh, not that one. You're gonna open it in Studio 5000. Once you open it, these are the two main things, or actually the only two things that you get. You get a generic Ethernet module, which is already pre-configured with the IP address that I already have from, if you recall, from here, 192.168.420. I also get this is pre-configured, so if I double click on that, it already has some things here, right? So the size of the inputs and outputs and configuration, and also the IP address. So I don't have to deal with that configuration at all. The other thing that you get is under the main program, main routine, you get these three rungs. And these three rungs are just basically to create, to map the data coming from the device into some variables that were created already. And these variables have actually some data types here, user-defined data types, okay? So don't worry too much about this. What we're going to do with these things is you're going to copy these things and bring them into your actual project. And that's what I have here. So this is my project. I'm gonna close all of this. And what you're gonna be doing is you're gonna grab from that L5X file that you created, you're gonna copy this generic module, and then you're going to paste it on your project, right? So I will just paste it here, but I already did earlier. So you copy and paste, and you're also gonna bring those rungs from this file, from the L5X, and you're gonna bring them into your project. But this is super important. Do not, and I repeat, do not just copy and paste. You have to actually export the rungs. So you're gonna have to do this, export rungs, and then on your project, you're gonna have to import the rungs. I already did here, but you're just basically, if you had an empty routine, um, you will just do this import rungs, and then you will bring them in. Okay, so that's what you will do. I already did that earlier. Okay, the next step is that you can actually close this L5X that you opened, because you basically use it for configuration at the very beginning. You can just close this. You don't need that for anything else. And actually, you can just log in with these three rungs that you had imported. Don't pay attention to this. We're gonna cover that in just a second. And you can download and see if everything's working right. It should be working right. So if I download, immediately, as soon as the download finishes, you're gonna see this light here, this indicator should be steady green, and it should say IOOK, like that. So that's actually very good. Now, if we go into the controller tags, you're going to see that you're going to have some tags already created there for you. So this is the raw data coming from the device. Don't pay attention to that. You don't have to worry about it at all. You actually have the data types. That's why we imported these rungs, these three, right? Because that raw data, it's passed into some data types, and now you see the signal coming back from the sensor. And there's something going on here. This is also raw data, but this is also simplified into data types. And what this is saying is on channel 0, so I have 4 ports on that IOLink module, right? Port 0 or port 1, port 2, port 3, and port 4. On channel 0 or port 1, I have already some data coming in. What is that data? Well, that is, going back to this file, that is this process data. Okay, it's coming in 2 bytes, so 16 bits. The problem is that this is still raw data. There's some byte swapping that we have to do. And I'm going to explain that using an Excel file that I created quickly here. We have to do some byte swapping because what's happening is if we pay attention to here, this process data, it says on the bit 0, you get the output, right? Like true or false, the Boolean output. True or false, am I sensing something or not? You get it on the very first bit, and that's why I have it here on the as output. Then the next bit is not used because it says the bit number 1 is not depicted here. So bit 1 is not used. And then from bit 2 to bit 15, that's where you get the distance, right? The distance that the sensor is measuring. So from bit 2 to bit 15, you get this information. What I did here, the reason why you don't see 15 here is because I just split this in 2 bytes. So byte 0 and byte 1. But I also created this row over here just to show the process data. Actually, this should say distance. And also here, distance, distance, and distance. So yeah, this is how it is explained in the datasheet, right? But when we actually look at the information on Studio 5000, you're gonna see, and if you wanna do it by yourself, you're gonna see that the data is actually swapped. So what happened is that this byte is actually here in API EP inputs mod 2, module 2, channel 0. So if I go here, it is, oops, it is here, channel 0, and then on synth 0. That's where that byte 1 is at. That's why I have these colors, right? So this is transferred to here, and this was transferred to here. Now, that is a problem because I can't tell what's the distance that I'm looking at right now. And actually, if we take a look at the hardware right now, you're going to see that I have here a measuring tape, and I think you can see it there on the video, but this measuring tape, I have 50 centimeters here, right? So the sensor is about 50 centimeters away from the wall. So I should be seeing, it's in the process data, it's in 0.1 millimeters. So I should be seeing 5,000, right? A value of 5,000, and I'm not seeing that. I mean, if we look at the data right now, I can't make up 5,000 from these two values. So how do we fix this? The way to fix this is that we have to use these instructions over here. This is a bit field distribute. And what we use these instructions for is just to rearrange this data. How are we going to do that, or what do we have to do? Well, basically what I have to do here is I have to, if I'm looking at the distance mainly, I have to grab this portion over here, because remember, this was the data for the distance started here. This portion, I have to grab it and put it at the very beginning, right? So it follows the same structure of the data. So I have to grab this and put it here, and then I have to grab this and put it over here. How do I do that? So I go back here, and the first thing that I'm going to do is I'm going to say, okay, source from byte 1. So you see here byte 1. And if we go back here, I'm telling it from byte 1, I want you to grab the second bit, and I want you to put it on bit number 0 of a certain variable of type int, right? So from bit 2, from byte 1 here, I want you to transfer it to bit 0 of this variable. Okay, how is that done? Is I use BTD and then source bit. So source bit is here, bit number 2. Grab it and send it to destination bit 0. So destination bit 0. And the length is going to be 6 bits. Okay, so 6 bits, this 6 over here. Perfect. So now I want you to do this and send it to this variable that I declared earlier, and this is of type int. Okay, now I still have to deal with that other chunk of data that I'm missing, this over here, right? So I'm gonna do exactly the same thing with a different BTD instruction. So I say now from byte zero from this data over here, byte zero, bit zero, I want you to transfer it to bit 6 of this process data. Okay, so source bit 0, oops, source bit 0 here, I want you to pass it to bit 6. I want you to pass it to destination bit 6, and this is going to be a length of 8. Why? Because there's 8 missing. Okay, that's how you rearrange the data. And this works with many other devices. It's not because of this device. A lot of the times you have to do this flip. So that's why we're using, or swap of this data. That's why I'm using this BTD instruction. And once you do this BTD and you re-download your project, you should end up with something like this. And now you can see that now the process data is reading 5,030, 31 or something like that. That means that I'm 50 centimeters or 500 millimeters away from the wall. How do I know this? Is because if you go into here, you see here it says distance is 1/10 of millimeter, so it's 0.1 millimeters. So 5,000 is 50 centimeters. If I want to check that, I'm going to try and put it closer. And this is going to be kind of like very empirical because I don't have any other way of doing this right now. But I'm going to try and put it around 40 millimeters. I think it's around there. And I'm away from my computer so I can see this point. But it should say 4,000, around 4,000, and it does. It's 3,980, right? So I'm still need to back it up a little bit, and my 4,000 is there. So now, if you see, I don't know, I think you can see there on the video. Yeah, you can. But here it's my 40 centimeters, so that's why I can see now the 4,000 value. Okay, that's awesome. So now we have the process data. This would be very important. If you also wanted to get where is this? If you also wanted to get this output, you can do the same thing and store this value in a bit if you wanted to, or you can create your own variable and just look at it. I think this was the most complex process here. But anyways, that's good there. Okay, so we're done with the process data. I'm going to pause the video right here and I'm going to explain how to read parameters and write parameters in just a second. Okay, for this next section, I'm going to explain the process of how to read a parameter first, okay? What I did here, and don't pay attention to this wrong, focus on the wrong number 4. What I did here is I just created a message function, or I just created a message instruction that I'm going to be using to read this parameter. And I just have a bit, and this is just bit is something that I can toggle manually to execute the message instruction. Uh, for you to have a better understanding of how this works more in depth, I strongly recommend that you download these files. So go into the Festo website and type in the part number or the designation for the Ethernet AP module, navigate to the support and download section over here, and then click on expert knowledge. And there we have this nice application note that you can just click on it, and then you can download it. And on that application note, you're going to be able to see what I'm going to explain. So the application note looks something like this. And I'm going to go all the way to the end, towards the end, the last section, and actually right here, right about here, I think. Yeah, so section number 8 talks about IOLink and maybe the process data that I was going through, you know, like byte swapping and all of that I explained right now for the process data. But we want to talk about how to access the ISDUs with explicit messaging. So how do we do that? I'm gonna skip all of these for now. I'm just gonna explain it on the fly here. The first thing that you have to do is you have to configure this message instruction, right? So let's open that message instruction and I'm going to show it to you here. So you're going to leave this as zip generic and service type is custom. The service code and the class, I think that most cases you're going to be using the same. What does this mean? Service code. So that's if you want to read if you want to read a single parameter or multiple parameters. So even this is defined here. So here, single conversion or all conversion. So for F service type, um, no, it's not service type. Yeah, service type. Service code is for F right here. If I wanted to get one single parameter, okay? So for F, and then 10b is the class that I have to use, and this is also it's also always going to be 10b in hex, okay? What else? The instance and attribute. So the instance is the index of the IOLink parameter that you want to read, and the attribute is the subindex of the IOLink parameter that you want to read. So what is this? If I go and open that user manual for my sensor, where is this? Here. And I scroll down and see the parameters. You're in every IOLink device, you're going to see that you have indexes and sub-indexes for the parameters, right? So for example, if I wanted to read the vendor ID, I would set this to the index is going to be 0 and the sub-index is going to be 8, right? And this should be defined somewhere here, here, vendor ID. So it says that the value for this vendor here, it's the value, it's 87. So maybe we can practice with that one in just a second. Okay, so if I wanted to read that, I will set that vendor ID, hold on, here. I would set index 0, subindex 8. So I will change this to 0 and I will change this to 8, right? Okay, now the source element. Pay attention to this part because this can be a little bit confusing. These two can be a little bit confusing. So the source element, not that one, but this one. The source element is here, and this is related to a table from the ODBA, this table over here, and it basically says what's the size or the conversion type that you're gonna be doing, right? And for this, you gotta look at, let's see what it says here. It says the value depends on the data being read. Example, if it is a 16-bit value, then the source element data is 15 decimal as per table C31. So if the value that I'm reading, for example, going back to my example about reading this is 8 bits, right? So it's a byte. If I'm reading a byte, I could set that to it's 8 bits, so I could set that to a number 7, this one over here. How does that work? So here you can create a variable or a tag. I created this tag that's called IOLconf type. And what I'm doing is I'm just setting the value, that 7 that I just explained here. No, not there. Here, this 7 here, this value, because it's 8 bytes and it's a value of 7 decimal. I write that value to this tag, that 7, right? That's how I do it. And then the source length, the next variable here, the source length, let's take a look. There's the source length match source element tag name data type. So in my case, I created a cent, so it's going to be 1 byte as well. So here I have 1 byte. And then the destination element. So the destination element, you got to make sure that whatever you're reading is actually going to fit into wherever you're sending it, right? Or wherever you're going to be saving it here or sending it into the Studio 5000 environment. So since I know that it's 8 bits that I'm going to be reading, I created a type sint. And this is just a variable that I declared earlier using this form over here. Now, that's it. Those are the only things that you have to configure here. On communication, this is very important. On communication, you have to define the path of where you're going to be sending this message to. So browse, I'm going to click browse, and then you're going to look for your module, right? The one that we imported. You remember the one that's under here on Ethernet down below? You're going to click on that, and that's going to bring this portion. Then you're going to type in a comma, and then if we follow the instructions from here, you're going to, it's like, I think it's up here. So then you're gonna type a number 3. A number 3 goes right after the path that I told you from the Ethernet tree. And then this is the important part. Which port on your IOLink master is this device connected to? The one that you want to read the parameter from. So in my case, it's connected on port number, on the very first port. On this document, they were connected on port number 2. But in my case, it was connected on port number 1. So that's why I have number 1 here, right? So again, remember, first portion is where you're communicating to or where you're sending this message. And then the next is just the number 3. I think it's always the number 3 all the time because of the ODBA spec. And the last number is which port are you communicating to. So in my case, it's port number 1. Now, they do mention something very important here, that if you have multiple IOLink masters under the same AP infrastructure, then they are sequential. So for example, if I had another IOLink master, it will start counting from 5 to 8. So the first one is 1, 2, 3, and it's actually 1, 2, 3, and 4. And then the second one will be 5, 6, 7, and 8, right? That's how it works, and so on. So if you have multiple IOLink masters. So those are the ports. Okay, so we got that. That's the only thing that you have to define here. And now I can just click apply and then click OK, right? Now, I haven't clicked switch this Boolean here. Once I make this true, I should see a value here, and that's why I have this equal instruction here. Just to, I have a nope here. I just want to see the value. So if once I make this true, I should see a value of what? I should see a value of the vendor ID, which is the one that I'm reading, and that should be an 87, right? This is the vendor ID for this company. So let's see. Toggle that bit, toggle bit, and there it is, value of 87, right? And you immediately get a done status over here. That's what you want to see. If you had something wrong, let's say, I don't know, you had something like 6 here, apply, toggle, now you get an error here, right? And this is going to tell you something. It's going to say undefined or unsupported attribute, okay? So that's because that index doesn't exist. So I'm going to switch it back to 0. And then OK, and make this toggle it and toggle it back, and then you see the 87. That's how you use the message instruction to read. The reason why I have this wrong over here, the wrong number 5, is because instead of me going back here and just changing these manually and going through the different variables or if I wanted to read a different index or sub-index, instead of me clicking in there, I can just assign it directly using these move instructions, right? That's how I do it. So if you take a look, right now it's 0 and 8, right? I assign this, and then I open this again, and you see now it's 1 and 7. So you can also do it that way if you want to. Okay, so next up, and the last portion of this video, it's going to be writing a parameter. Okay, so we'll start doing that in just a second. Okay, so now for the write it's kind of similar to the reading. You can see I also have the same structure here. I just have a write bit here, and I have a message instruction for writing. The configuration under the message instruction for writing, at least the communication is exactly the same. The configuration changes a little bit. So now I have a different service code, and that is because if we go over here, this table was for reading, the one that I showed you earlier. So get parameters, and then this one is for set parameters, right? So if you want to set a single parameter is the 50, that's the service code, and then the class is still the same, I believe it's 10b. So let's see, oops, 10b, and you can see on the reading it was 10b as well, so that doesn't change. Then the instance and attribute is the same thing. It's the index and subindex that you want to write to, index and subindex. And remember, depending on which one we want to do. For example, in my case, I want to write actually this value over here, this one. So it says the index is 1, 1. The subindex is 3, and within the subindex, I just need to focus on bit 5 and 6. In this particular sensor, you gotta be careful about that because this subindex is shared with different parameters, okay? But anyways, don't pay attention to that at this point. It's just 1 and 3. So for this instance, 1 and attribute 3, so index and subindex, and then source element, source length, and destination element. So this is just a little bit different than it was on the reading. For the writing here for set, so source length is um, this number, it's going to be 2 bytes that you're going to be using for the length. So these 2 bytes over here. And then you're going to have the conversion type data, this one over here. And the last one, it's going to be the actual byte for the data that you're going to write to the parameter. Okay, so that maybe at this point it doesn't make a lot of sense. I'll just explain it here in just a second. What we're going to do in my case is we're going to look at this example that's down below here, writing over here, and it might make more sense here. So data byte 0 I'm talking about the source element, okay? Let's see, source element. So data byte 0, it's 1, and that's, I think they say here it's almost always 1. Byte 1, it's 0, no additional values. Byte 2, if you recall from that table that was over here, where is it? This table over here. In my case, if I look at the sensor here, it says that the length of this subindex, it's actually 8 bits. How do I know this? Because I have to actually sum these bits over here. So 0 to 3, 4, 5 to 6, and 7. So it's 8 bits. So that's 1 byte, right? 8 bits or 1 byte. If I want to do 8 bits, I'm going to have to use a number 7. Okay? Number 7, where? The number 7, it's going to go in this byte number 2. I'm not sure. I'm trying to. I can see your face right now. It might be very confusing, but let's see if it makes more sense once we are once we are in this 35,000 environment. So just bear with me for just a second. That's byte 2. Then by the next byte, it's actually going to be the data that I'm writing. Okay, so let's go to 35,000 and see how that looks. So what I did here, for the sake of explaining what's happening, is I just split this variable that I created here, source data, and this is of type source data. It's of type sint. It's an array of 4 sint, or 4 bytes. And let's look at it. The first byte, so byte 0. Byte 0, it's always 1. Okay. So byte 0, it's always 1. That's why I have it set to 1. Byte 1, it's always set to 0. Byte 1, it's always set to 0. Byte 2, now byte 2, this one is the one that explains what does it say here? The data type, the data type conversion, right? Here, conversion type. So in our case, we're only writing 8 bits, so this must be a number 7 because it's 8 bits. That's why I have a number 7 here, right? Why am I saying that it's 8 bits? Remember, because of what I mentioned here, the sub-index that I'm writing to, so this, it's 8 bits if I sum this 4 over here. So 1, 2, 3, and 4, and you see it starts from bit 0 to bit 7, so it's 8 bits. Okay, so now we know that we're transferring 8 bits. That's why we have that 7. I'm just going to repeat myself again. Just want to clarify. That 7 comes because of the 8 bits. Okay, and then the next byte, it's going to be, okay, what's the data that you want to write? And in my case, I want to write a number 96. Why? Because as I mentioned, I already showed you there, but as I mentioned here, I want to modify only this parameter, the sonic cone, and I want to set it as a 3, the standard. This would mean that if I want to set it as a 3 with the combination of these 2 bits, I need to do that. So if I open my calculator and I do that, I set bit number 5 and 6, that will give me my 3, right? My number 3 between the combination of those 2 bits. It would be bit 5 and bit 6, and that's equivalent to a 96 decimal. Okay, so if I graph this value, that means that, let me put this on the side. That means that if you look from here to here, I'm gonna leave this to 0, this to 0, this I'm gonna change it to 3, and this is gonna remain at 0. You see here, 0, 0, 0, 0, and then the 3, and then 0. Okay, so 96. That's why if I go to Studio 5000, I have a 96 here on my last byte, because that's what I'm transferring. So if we go back here, that's the dissection or dissection of this variable. What I just explained with these 4 equals here, it's the dissection of this variable here, and I'm transferring the source length is 4 bytes, and the destination element, I can just use this same variable that I used before on the read. I can just reuse it here, it doesn't matter. Okay, so you can close that. I'm going to write this. I think it should be the same values that I have in here already, 1 and 3. So you can see here 1 and 3. So that's fine. I'm just gonna write it. Assign the parameters. Control T. And now I'm going to do the write. So toggle. And I already had the done because I did it earlier, but you can see it's currently enabled and it says done. Okay, so that's good. Now, if I go back here, and again, I already tested this earlier, that's why I already have the number 96 there that I already transferred. But if you want to see that I'm not doing any tricks here, I'm going to change it back to 0 and 8 to read that vendor ID. I'm going to read that first. So 0 and 8. And let's read that vendor ID. Assign that to the message and then read. So there's my vendor ID, 87. So 87, yeah, 87, that's the vendor ID. And now we want to check if we truly have what I wrote earlier, right? So where was that? That was on 1 and 3, right? I think index 1, subindex 3. So index 1, subindex 3, they share the same subindex. So read index 1, read subindex 3, assign these parameters to the message because I haven't toggled it right now. Remember that we just read the vendor. So I'm going to change that, assign. And now you're looking here, and now it's 1 and 3. Here, 1 and 3. And now I can read that. And I should get that 96 that I wrote previously, right? So read parameter, toggle, and here you have it, the 96. So I'm just confirming that the parameter was written. And that's about it. That's how you can read and write parameters just using the message instructions and also the process data. So we covered the basic functionality that you get out of an IOLink device over Ethernet IP. Thank you for watching.